Hello everyone. In this recording we will talk about design of experiments. So the outline will be that I will first talk about the factorial experiments, and these factorial experiments will be single factor, and then we will talk about the full factorial and then talk about the fractional. This is how we design the experiments. Okay, so this one is the design of experiments. And then the next step will be that we will talk about the hypothesis. Okay, so as you know, before the experiment you have some hypothesis. Okay, so and after the experiment you have also some hypothesis. The idea is that we have to check the hypothesis before the experiment. Okay, so the hypothesis before the experiment, we check it after the experiment. Okay, if it is true or not. Okay, should we accept the hypothesis before the experiment, or should we reject the hypothesis before the experiment? This will be second part of today's lecture. Okay, so the experiment. So we have a simple experiment here. It says that we are trying to understand the effect of engine size, like small or large, tire type, like all season and performance, fuel type, regular, premium, and then load, light load and heavy load. So what is the best efficiency? Okay, best fuel efficiency, and then how do we find it? Okay, that is the main question that we will focus on today, and then we will apply different design of experiment techniques. The first thing is that you can easily do is that you can write all combinations of the variables. Okay, you can say that the first experiment will be that small engine, all season tires, regular and light load. Okay, and then you take the small all season tires, regular, but this time change it to heavy load. Okay, small again, change the fuel to premium and then light load. Okay, so this way you try all combinations. Okay, this is the easiest solution that we can do. Okay, but the reason that we don't use this one is that this one takes time and it takes cost. Okay, because here we have 4 variables, 4 factors. But if you have more factors with more levels, like you have small and large engine, if you have the medium engine, okay, and then if you had the tire type, like one more tire type, or a fuel type, you have one more. So then the number of experiments will go up. Okay, so now it is 16, it may be like 50, it may be like 60, it may be like 100, 200. Okay, so that's the reason that we are trying to get and conduct and plan experiments to have the maximum amount of information in the fewest number of runs. Okay, that is the main part of today's lecture. So we are trying to find the maximum amount of information in the fewest number of runs. Okay, so I will give you one example here, is that the comfort zone. Okay, this one is the comfort zone. So we have the humidity here, okay, and then we have the temperature. As you can see, so the comfort zone is between, for the temperature range, 67 up to 80. Okay, but for humidity it's from 20% to 68%. Okay, but depending on it is whether winter or summer. So the thing here is that so we have two effects. The main effect, okay, like for example, so how temperature affects the comfort zone, okay, and then in this case we keep the relative humidity constant. Okay, so what means is that I change the temperature. For example, I started here, which is I move this way and then that way. You see humidity is constant, okay, but still I'm not in comfort zone. But then I jump into comfort zone and we are out of the comfort zone. Okay, this is one main effect. Second main effect would be that we are looking for how relative humidity affects the comfort zone. Okay, and in this case the temperature is constant. Like I go this way, up, temperature is constant, I'm in comfort zone, we are in comfort zone, okay, and then we are out of the comfort zone. And then we have the interaction effect as well. For the interaction effect, so we are looking for how the both effects, so both temperature and then relative humidity affect the comfort zone. Okay, in this case we change both together. Okay, so instead of moving in one way, so we go like this way. Okay, you see that temperature and then the humidity also changes. Okay, this is one example. Second one would be that like we have the salt that adds some flavor, we have pepper that adds some spicy flavor, but when salt and pepper are together, so the influence is not simply the sum of their individual values. Okay, so if I go back for this problem, so you may be comfortable at the temperature of 60 Fahrenheit. Okay, you may be comfortable at temperature, at humidity of, let's put as a 675 Fahrenheit. Okay, you may be comfortable at the relative humidity of like maybe at 80%. Okay, you see that 80% is also the comfort zone in winter. Okay, but 75 Fahrenheit and 80% comfort zone is not the simply addition of the comfort zone at 75 and 80%. Okay, because this one we don't like it. Okay, because humidity is very high. But this one simply is good in winter. Okay, but this one is also good in winter, but the sum together is not good. Okay, that's what it means. Or exercise, for example, burns calories. Diet also helps you, but both exercise and diet together, they have more effect than exercise and health summed effect. Okay, so this one, like say that has an effect of 10, this one has an effect of 8, but these two has an effect more than 18. Okay, or more than 8 plus 10. Okay, the interaction effect is more. Okay, so that's the reason that we have to design the experiment. Okay, so we have to design in a way that we change the variables one by one, and then we change the variables together as well. This is called a factorial experiment. Okay, so as you see that the design of experiments helps us to see the interactions between the variables, okay, and it helps us to get more information about the experiment. And then, as you will see in the next slides, we can also decrease the number of experiments and get the information as required, as needed. Okay. So there are some terminology involved in design of experiments. So let's start one by one. Some terminology we don't need for this introductory class, but for more in-depth involved classes, you may need all of the terminologies. But for today, you will only need what's factor. Factor is just a variable, parameter. It may be the size of the engine, it may be the type of the tire, it may be the fuel type, or it may be the load here. Okay, you see? We have 1, 2, 3, 4 factors. Okay. And then we have the response variable. Okay. So response variable would may be that. So you are looking for the influence of these factors on fuel efficiency. Okay. Or the response variable may be that you are looking for the influence of these parameters on miles per gallon. Okay. These are the response variable. These are, you can say that, dependent. But these are independent. And then we have the interaction effect. As we talked about, the interaction means that the variables itself interact with each other. So maybe that when you have, like, for example, the engine size and fuel type, okay, so they have some type of interaction. Okay. For example, if you have a large engine that needs premium fuel, okay, this is what interaction means, that variables interact with each other. And then we have the treatment and then run. Okay. Let me give you one example for the treatment. So for example, we can take the engine size as small. We can take the tires as all season and fuel type as premium and then load as heavy. Okay. And then we can run the experiment once. So you run it, it will be one time again. So you can again run it. Okay. Then you will have a second run, but treatment is always the same. So what it means is that you can repeat the experiment, that you will have more runs, but you will have the same number of the treatment. Okay. So you have the same treatment, but you run it multiple times, for example. Replicate is that, so you repeat the entire experiment for detecting whether it changes or not. Okay, so for example, you have some survey, okay, and then you conduct a survey on 10 people, and that is a replicate because you run it on, instead of running once, you run it 10 times. Okay, that's the replicate. So for example, we have a simple problem here that says, so we have a plant that tries to optimize the production of metal parts. Okay. We have the goal of studying the effect of machine type, the cutting speed, coolant type on the surface finish quality. So in this problem, we can list like this way. Okay, so you see, we have the machine type, the cutting speed, coolant type, and then surface roughness. Okay, we have the factor here, which is these three of them. Okay. Response variable, if I go back, is the surface finish quality. You are trying to see what are the influence of these parameters on the surface finish quality. That's the response variable. And treatment is that, like as I told you, you choose one combination of the parameters. You choose machine A, cutting speed 100, water-based. Okay, this will be one treatment. And by the way, you can add more experiments. Okay, this doesn't mean that this ends here. You can add more experiments. And run, as we said, you can run this experiment. But if you run the same experiment on multiple times, then you will have the replicate. Interaction may be that there are some interaction. For example, it says that if you choose machine A and then cutting speed, it will have more impact on roughness when combined with oil-based coolant. Okay, so what it means is that let's just go here this way. So say that machine type, this one has an effect of like 10. Okay, this one has an effect of like, let's say 10%. This one has an effect of 20%. This one has an effect of 30%. Okay, separately. This one is independently, this one is independently, this one is independent. But when you run them together, the combined effect is not 50-60%. Okay, the combined effect may be more than 60% or less than 60%. Okay, that's what it means, the interaction effect. Okay, so then we will continue in our next recording on this single factor experiment. Let me stop it.